Hello, this is Samuel Hassler, and this is my report on, or my overview, my video coverage of Exercise 3, Traffic Lights assignment for the Cyber Physical Systems course. So here's the actual exercise. It seems to be pretty open-ended. It just kind of gives us what we need to do. And it just kind of seems to be up to us to try to develop something that makes this work under these parameters. Starting with the ladder logic here, the big things here are the safety mechanisms. So I need to be sure that to light up green, it has to have a check that the red LED is on and the green and yellow LED is off on the vice versa. And it's the same for yellow. And here, let's see, you can see what I did here. So here's that check. So it's saying if the other red light is on and the other yellow light is off and the other green light is off, it goes in here, and then it will light up this green LED right here. There's some logic here involving a timer so that it actually shuts itself off. So like this N here is actually, it's a default, or it's a negated, it's not. So until the timer goes on, whenever this timer goes off is when it shuts this off. Anyways, the same logic applies to the yellow here. If you can see this, it traces back and it comes out of the same little group here. So both checks are done for the green and the yellow. I know it's probably really hard to see this. I copied it. So this is one traffic light for the north and south, and then here is a traffic light for the east and west side. It's pretty much just copied with the variable names like flopped to the other one. And then for the red lights, I just checked to see if, since there wasn't any specific requirement for the red light, I just said whenever the green light and the yellow light is off, turn the red light on, which makes sense to me. It seems like the simplest way to implement that. And then I have these counters here, which are tracking the timers of things go on. It wasn't super clear, in my opinion, whether or not, let's see, should display a counter next to each light in the stack that counts down to transitions. I didn't know if that meant like keep a running total as like the program goes along. I just did it based on these counters here. So like in 5 or 10 seconds before, it'll start counting down. I assume that was good enough. I could have implemented it the other way, but I wasn't sure what you wanted, or what this assignment was wanting, rather. So anyways, that brings us to, I uploaded it to the PLC here, and then here's my HMI that I made. Here's the background image, and it's actually running right now. So here the green light's on, and the yellow light turns on in 2 seconds, 1 second, red light's on. Red light, or yellow light. The red light turns on now, and you see the timer for the next one for every cycle. So I'll let this run for a second just so you see that it's working correctly. Okay, and then over here we have the physical part. I apologize, my lighting is really bad right now. One of my lights went out, so in my living room, and I don't have another bulb at the moment. But the physical system was like very straightforward. This is the north-south stack. So you can see the green light will turn on for 10 seconds, and then it'll swap to the yellow for 5, and then the red until it comes back to the green on that. So yeah, there we have it.